In this video, I'm going to talk about how to use test instruction, how to use compare and jump instructions. The test instruction is similar to AND instruction. The AND instruction is going to compare destination operand with the source bit by bit. The test instruction is similar to AND. The only difference between test and AND is test won't modify the destination operand, but it performs AND instruction without changing the destination. Use test instruction, you can make a jump after that. So after you have a test, you can see you have a result. Based on your result, you can make a jump. Here we have an example, and this example is going to jump to a label value found if bid 0 or bid 1 in AR is set. This is bid 0, this is bid 1. So we want to know either one of these is set or not in AR. We use a test, and if we test this with this, we don't have a 0. That means either bid 0 or bid 1 in AR is set. So we're going to jump to a location called value found to do some kind of processing. This is another example. We're going to jump to label value not found if bid 0 nor bid 1 is set. So we test out by using test or AND here. And we leave this, we take these two bits out from AR. If none of B01 is set in this, the result will be 0 from this statement. So we can say jump 0 and value not found. Compare instruction is going to compare destination operand with source operand. Here, we're going to copy 5 into AL, and we're going to compare AL with 5. We know AL equals 5. So in this case, destination equals source. In this case, after this statement, the 0 flag will be set to be 1. When you compare, if your destination is less than your source, like this one, 4 is less than 5, and the carry flag will be set to 1. When you compare, destination is greater than source, here 6 greater than 5. In this case, 0 flag will be 0 and the carry flag will be 0. We can use compare to compare signed integers. Signed integers with positive or negative. If destination is greater than source, here 5 greater than negative 2, and if this is the case, sign flag will equal overflow flag. If destination less than source, negative 1 less than 5, and in this case, sign flag won't equal overflow flag. Conditional jumps. We can jump based on some flag values, based on equality, or based on signed or unsigned comparisons. Specific jumps, you can jump below, jump when carry set, jump equal, jump 0 flag set, jump sign flag set. So there are many combinations we can use when we make a jump statement. This is a table. Tell us the jump based on some flag values. You can jump based on 0 flag, jump 0 when ZF equal 1, jump not 0, that means when 0 flag equal 0, jump carry when the carry flag is set to 1, jump not carry when the carry flag is 0. So jump overflow, jump sign flags on, jump parity flags on. Or jump equal, jump not equal, jump when CX equal 0, jump if ECX is 0. For unsigned comparisons, we can use jump above or jump below, jump not below equal, jump above or equal, jump below or equal. So you can make many different combinations for unsigned comparisons. Same thing, we can make many combinations using signed comparisons. For signed comparisons, we use jump greater than, jump less than, jump greater or equal, jump less or equal. So you can try out these combinations when you do signed number comparisons. Here we see there are 5 applications. Application 1, task jump to a label if unsigned EAX is greater than EBX. So we're going to compare EAX with EBX. Then we're going to say jump above. That means when EAX above EBX, we're going to jump to a location called larger. Second task, we're going to jump to a label if signed EAX is greater than EBX. For signed number, you need to use jump greater than or jump less than. So when we compare EAX with EBX, if EAX is greater than EBX, we go to location greater. Another jump for unsigned, if unsigned EAX is less than or equal to. So if it's less than this one, less than or equal to variable 1, go to label L1 for processing. This one is for signed EAX. So we compare EAX with variable 1, we say jump less equal. If EAX is less than or equal to variable 1, we go to L1. Application 3, and how to find out the larger one between AX and BX. And you are going to copy the larger one from AX or BX into large. So you need to have a variable large. You're going to, the beginning, you're going to copy BX into large. Then you're going to compare BX with AX. After this, you're going to make a jump statement. So if AX not above BX, that means BX is larger, and we have BX in larger. So we just go to next, do some processing. If not above, that means BX greater, you jump. Otherwise, you're going to process this statement, copy AX into large, then continue with the processing following here. And let me show the coding in the Visual Studio. I made a complete program to find the larger number between AX and AX. I have prompt 1, I have a variable larger. In my main procedure, I manually copy 100 into AX or 200 into BX. Then I'm going to put a BX into larger by default, then compare AX with BX. Then I'm going to say jump not above. That means when AX is less than or equal BX, I just continue to here to do the processing. This next section is going to print out the larger number. So I'm going to use call write DEC to write decimal format. Before I do it, I clean up AX. Then I can copy whatever is larger into AX, then call write DEC. Then I print my message is the larger number after the number. So when you compare AX with BX, and when it's not above, you jump to next, print out the larger immediately. Otherwise, you stay here, and that means AX is greater or above BX. You have to copy AX into larger, then continue with the processing. Okay, let me run the code to show you the result. $200 is the larger number, and you can see from here I have 200 in BX. Let me change, suppose I change the first one into 300. Let's see if my code is working right. And build, and I'm going to extract. Yeah, 300 is the larger number. So this is the code to find out the larger one between two variables or two registers. Here, let me continue back to the PowerPoint. So this is how to find out the larger between two numbers. You also can write the code to find out the largest between three registers or three variables. Or you can write a loop to process to find out the largest one in an array. This is a code how to compare AX with BX to find out the smaller one of the two. You can copy X into small by default, then compare BX with AX. Jump not less than. That means if AX not less than AX, you're going to go to next processing here. Otherwise, you're going to copy BX into small. That means BX is smaller than AX. So you can copy this out in your Visual Studio. Try this out on yourself. Application 4. You're going to jump to a label L1 when the memory word point to by ESI equals 0. So you're going to compare a word pointed by ESI with 0. If ESI is pointing to 0, and that means you're going to jump to L1 because you're using jump equal. This jump going to jump to label 2 if double word in memory point to by EDI is even number. So to test out a number is even or odd, you need to use test operand with 1 or AND operand with 1. So I wanted to know EDI is pointing to a even number or odd number. We need to say compare the double word pointed by EDI with 1. Then if it's 0, that means you find a even number. You jump to L2. You do even number processing. I have a coding example. You can check out in the videos section. One more example. We want to jump to label L1 if B is 0, 1, and 3 outside. This is the coding. We're going to use AND. If you don't want to modify the destination AL, you better use test to replace AND here. So to test out the bit 0, 1, 3, you're going to leave this 3 as 1 and mark off all the rest bits. And this is going to let you take out these 3 bits from AL. And if you have, after you take them out, you're going to compare it AL with this number again, and then jump equal. That means if AL equals this, that means all these three numbers are set. You're going to jump to L1. So this is how to use compare jumps on the tests and instructions. Thank you for watching.